Okay, so we move on to chapter 5, conditional probability, which is a very short chapter, essentially a building block chapter to more difficult things. So I'll only spend one video on this. So obviously we've got the definition, we've got A and B being events, and the probability of B not equal to 0. Then the probability of A given B is equal to probability of A intersection B over the probability of B. Obviously, I know in his notes he's got a colon sign here just before the equal sign. Obviously, that's because A given B is a meaningless expression. And so, oh, sorry, the camera just knocked the camera a bit. And so obviously we're giving it meaning, which is the right hand side. So I am aware that that there is a colon in the actual notes, but obviously it's exam time now. I'm just going to use the equal sign. And this scenario, I've got an actual example to go through, but first I just want to briefly mention this question from an exercise sheet, which is something really to look out for, especially since you're going to be revising a lot of things over the next couple of months, and something like this is very, very subtle but can cost you a lot of marks. So, and this scenario is a really good demonstration of it. It's out of all students graduating with first class degrees in maths from Queen Mary, 96% of them passed the midterm test in introduction to probability. A student concludes that since he has just passed the test, he has a very good chance of getting a first. And the question was actually, what's the flaw in his argument? Well, the flaw is that he's got it the wrong way around. It's saying that, of the students graduate with first class degrees in maths from Queen Mary, 96% of them passed the midterm test. So what they're saying is probably of passing the test, given that you got a first, which is what the first sentence says, that was 0.96. But what the student has said is that the probability of getting a first, given that you pass a test, is 0.96, which isn't the case. It's a simple case of just getting the things the wrong way around, and understandably so, because these are very similar. But it's just something to watch out for, because you're going to be revising 12 weeks of probability and then all the other modules, calculus and whatever else you have, and so something like this, it can be very easy to trip up on, especially if you just sort of underestimate a conditional probability question, which will be probably easy in the exam if it's given on its own, but this can really trip you up. So that's just something to be aware of. But yeah, let's go on to an example. So let's see here. Right. So an electronics store sells 3 different brands of DVD players. Of its DVD player sales, 50% are brand 1, 30% are brand 2, and 20% are brand 3. It is known that 25% of brand 1's DVD players require repair work. 20% of brand 2's DVD players require repair work, and 10% of brand 3's DVD players require repair work. And we'll start with the first question. What is the probability that a random selected purchaser has bought a brand 1 DVD player that will need repair while under warranty? Ignore the warranty bit. That's just, I'd wrote out the whole question, but I didn't mention it in the paragraph. Basically, this is from an exercise book. And so in the scenario, basically, that when they purchase a product, they get a warranty of a year, and within that window, they can obviously get repaired. The warranty doesn't actually have any effect on the question. It's still, the probability that they bought a brand 1 DVD player that will need repair while under warranty. Okay, so let's define some events, right? So let's see, I've got brand 1, brand 2, brand 3, and we've got, each of them needing repair. So what we're going to do is we're going to let AI... Let AI be the event. So we're going to sorry if that's not clear, we're going to let AI be the event brand I has been brought. Okay, and obviously I is going from 1, 2, and 3 because there's only 3 brands. And then we'll let R be the event the DVD player needs repair work. Needs repair work. I'm just going to write it down here because it's a bit of a stretch to get that. Right, okay. So, what do we know? So we'll start with the second sentence. So what's that? Of its DVD player sales, 50% of brand 1, 30% of brand 2, 20% of brand 3. Okay, so we can write that down. We can write the probability of brand 1 being bought, which is obviously it being sold, same thing. That's going to be 0.5, which is a half. The probability of brand 2 being bought, well, that was 30%, so that's 3/10. And brand 3, that was 20%. 20% of the sales were brand 3, so that was 2/10, right? Or I'll just write that as 1/5. Right, and what else do we know, right? So next sentence says, it is known that 25% of brand 1's DVD players require repair work, right? So the probability that it requires repair work, given that it was brand 1, was 0.25. And then this is the case. It's 20% for the case of brand 2, 10% for the case of brand 3. So what can we write here? Well, we can write that the probability that it needs repair work, given that it's A1, is 1/4. The probability that it needs repair work, because obviously that was 25%. Probably that it needs repair work, given that it was A2. Well, that was 20% of brand 2, so 20%. So that's 2 out of 10 again, so 1/5. And then we've got the probability that it needs repair work, given that it was A3, given that it was it was a brand 3 product. Well, that was 10%, so that's 1 out of 10. Okay, so we've got all the information that we can get from that question and the from the scenario, and the question was, what is the probability that a random selected purchaser has bought a brand 1 DVD player that will need repair while under warranty? Okay, so we want the probability that it's a brand 1 DVD player and they need repairing, right? So that is going to be, let me just get some new paper here. That is going to be the probability of A1, since it's brand 1, and it needs repairing. So it's going to be A1 intersection R. Well, what's that going to be? Well, by the definition of conditional probability for any events A and B, we want A1 intersection R. Well, if I times both sides by probability of B, I can make this a subject and thus derive that. And obviously I've got these two values, because obviously A given B here is R given A1. So the probability of A1 intersection R, well, it's going to be this times this by rearranging the definition of conditional probability. So I'll just write that down. So it's going to be the probability of R given A1 times probability of A1, which will be 1/4 times 1/2, which will be 1/8. Okay, so that's a pretty simple question. So the second question was, what is a probability that a randomly selected purchaser has a DVD player that will need repairing? So there isn't they haven't stated the brand, so it could be any of the brands. It could be brand 1 or brand 2 or brand 3. Obviously, it's going to only be one of them, so it's not DVD players, it's just DVD player. So they've only bought one. So we want the probability that it needs repairing. Basically, that's what we want, because there is no specified brand. We just want the probability that it needs repairing. Well, what's that going to consist of? Well, it could be that it was A1 and needs repairing. So it could have been brand 1 and then needed repairing. Or it could have been brand 2 and needs repairing. So we're going to add on, A2 intersection R. Or it could have been brand 3 that needs repairing. And that's A3 intersection R. So, well, what's A1 intersection R? Well, we know that from the previous question. That was 1/8. A2 intersection R, well, I'm going to work that out the same way I did A1 intersection R. That's going to be the probability of R intersection A2 times the probability of A2. That's still the probability sign. Sometimes I just get in the habit of putting a line through it, like you do for all, sort of like sets like integers and, rationals and all that stuff. But yeah, that's just a probability sign. Plus the probability of R given A3 times the probability of A3. Hopefully that's clear. That's meant to say A3. Let me just rewrite that. It's not very clear on the camera, so hopefully that's a bit clearer. But yeah, just barely fit that in. So what's this going to be? Well, this is going to be 1/8. This is going to be, well, R needs repairing given that it's A2. That's going to be 1/5 times that it's A2. That is the second brand. So that's 1/5 times 3/10. Which should be, and what is that? Is that 3/50? 3/50? Yep. 3/50. I've got it as 6/100. Just for the sake of, I haven't simplified it. Well, yeah, it's 3/50. And then we have probably of these repairing given A3 times probability of A3. So that's 1/10 times 1/5, which is 1/50. So yeah, and I've just wrote that as 2/100. Because obviously in exam it's just easier to simplify them. And yeah, so when you add these up, you should get 41/200. So yeah, I just didn't simplify them because in the exam it's just easier to have these over 100. But yeah, so that should be, that's the answer to R. Not answer to R, answer to the second question, but that is a probability of R. Now we've got the third question, which is that if a customer returns to the store with a DVD player that needs repairing, what is the probability that it is a brand 1 DVD player, a brand 2 DVD player, or a brand 3 DVD player? Or not, or a brand 3 DVD player, sorry, just a brand 3 DVD player. So these are 3 independent questions. So now we know that they have a DVD player that needs repairing, but we want the probability that it is a brand 1 DVD player. So we now want the probability of brand 1. So we want the probability that it's brand 1 given that it needs repairing. Hopefully you can tell the difference between that and the probability that it needs repairing given that it's brand 1. Here we actually want the probability that it's going to be, brand 1, brand 2, or brand 3. Before, we were wanting the probability that it needed repairing. So that's why I've got A1 given R instead of R given A1. So what's that going to be? That's going to be the probability of, by conditional probability, that's going to be A1 intersection R over R, and that's by definition of conditional probability. And so we know what A1 intersection R is. That's 1/8 from the first part of the question, and we know what probability of R is. That was from the second part. That's 41/200. And when you simplify this, you should get 25/41. Now we've got that the probability that brand 2's DVD player, that's going to be A2 given R. And again, by definition of conditional probability, that's A1 or A2, sorry, intersection R over probability of R, and that is going to be, what's that going to be? That's going to be 6/100. Was it 6/100? Yeah, 6/100, or 3/50 if you have that, that's fine. over 41 over 200, and that simplifies to 12 out of 41. And then you got the final one, which is A3 given R, which is the probability of A3 intersection R over the probability of R, which is 2 out of 41. Okay, so that's all the questions answers. Hopefully that was clear. I've spent quite a lot of time on conditional probability. Obviously, it's only one video. I'm sure you could do most of this anyway. Sorry if it felt a bit rushed or was a bit maybe I rushed you a little bit. I'm not sure. But hopefully everything's crystal clear. I definitely went through it slow enough that you understood, or you should have understood, using conditional probability. Again, this is really just the foundation of using conditional probability. You will go on to use it, more often and see more powerful results with it later on. There is a theorem for conditional probability, and that's for n events, and that is that the probability of A1 intersection A2 all the way to AN is the probability of A1 times the probability of A2 given A1 times the probability of A3 given A1 intersection A2 all the way until you get to the probability of A intersection N given A1 intersection A2 AN minus 1. Now we haven't shown this result really extensively or where it's used, but there is an example in the notes of that, and it's illustrated pretty clearly, so that's why I haven't got an example on it. But obviously do remember this result is quite a key result that you may need to lose an exam, you may not, you never know. But that's just something I just want to mention anyway, just briefly. But yeah, the example in the notes is pretty clear on where this is used. But yeah, I might put a video on it in the future, focusing on that once I've covered the whole module. So the next video will be on independence, and yeah, I think that will conclude chapter 5.